Yes, hello. Thank you. My name is Zachary Gazicki. I'm a senior restoration ecologist at H.T. Harvey and Associates. Today, I'll be discussing one approach for habitat enhancement as part of living shoreline project considerations, the high tide refuge islands. High tide refuge islands are constructed earthen mounds within the marsh plain, which serve as refugia for wildlife during extreme high tides. The photo here is an example of a high tide refuge island taken from Cooley Marsh of an island constructed just 1 year earlier during high tide. Next slide, please. I'll be going over a little bit of background and goals for creating these refuge islands, the basis of design and construction methods, our monitoring approach and results, and lessons learned. This photo is a photo of Refuge Island from Muzzy Marsh, taken about 3 years after construction. Next slide, please. So, as Jeannie mentioned, one of our main target species for these high tide refuge island enhancements is the state and federally endangered California Ridgway's rail. Now, historically, these birds occupied tidal marshes from Marin all the way down to San Luis Obispo. Today, populations are solely found within the San Francisco estuary. According to Point Blue, rail populations have declined from approximately 4,000 individuals in the 1970s to a little over 1,000 in recent years. Now, it's worth noting that the methodologies for this graph here differed throughout the years. However, I just wanted to kind of point out the general trend that the birds have decreased, but are starting to increase in certain areas. Some of the major threats to rail populations include habitat loss, sea level rise, and predation. Next slide, please. One of the main factors affecting rail populations is high predation rates, exacerbated by a lack of high tide refugia. In mature tidal marshes, high tide refugia is provided by transition zone habitats at the edge of marshes, as well as mature gum plant and other tall marsh species, which establish long, slightly elevated berms along the tidal slough channels. The photo on the left was taken during a king tide at the Palo Alto Baylands. In it, you can see a rail that has been driven from the tidal channels where it usually forages. This is a time when rails are particularly vulnerable to aerial and terrestrial predators and apparently opportunistic photographers. Um, Gumplant line slough channels play a key role in providing in-marsh refugia habitat, as shown in the photo on the right, which shows China Camp during a king tide. Next slide, please. Now, as mentioned, ironically, hybrid Spartina, which Tobias and Jeannie just presented on, can actually provide fairly decent in-marsh refugia for rails during high tide. Next slide, please. Therefore, one of the goals of these high tide refuge islands is to create refugia during extreme high tides in the face of sea level rise and as hybrid Spartina continues to be eliminated from marshes. The hope is that these islands will reduce predation and increase rail populations. Now, as we heard from the previous presentations, these refuge islands are just one part of a larger suite of habitat restoration efforts being provided by the Invasive Spartina project. Next slide, please. The design of these refuge islands mimics the refugia function provided by gumplant lined slough channels and other tall marsh vegetation within mature tidal marshes. Next slide, please. The first step in the design process is deciding where to build these refuge islands such that they'll provide positive impact on rail populations. We've collaborated with OEI, the USGS, Point Blue, and the US Fish and Wildlife Service to develop location selection criteria. Rails require access to an intricate network of slough channels to provide abundant invertebrate foraging opportunities and escape routes from predators. Therefore, our refuge island locations have been selected based on the criteria shown. They should be within 300 feet of rail detections. They should be located away from other sources of refugia. They should be located close enough to slough channel networks, ideally at a slough channel confluence, which will maximize the benefits. They should be located away from known predation sources. They should avoid areas of hybrid Spartina which are actively being treated. And they should be in areas that can be easily accessed by the crews who will be constructing these features. Next slide, please. Since 2012, 82 refuge islands have been constructed across 13 marshes around the San Francisco Bay. Initially, 6 islands were constructed as a pilot project, and 16 additional islands were constructed during the winter of 2013-2014. These first 22 islands were required by the U.S. Fish and Wildlife Service in areas where hybrid Spartina was being removed. The Coastal Conservancy has since constructed an additional 60 islands voluntarily to enhance rail habitat bay-wide. This figure just shows a snapshot of where the different refuge islands have been located across the San Francisco Bay. Next slide, please. In collaboration with OEI, ISP, and the USGS, we came up with a design to construct small, about 25 foot long by 10 feet wide islands adjacent to tidal slough channels and marshes with rails and in need of high tide refugia. It's basically that little kidney bean shaped feature there. The goal is to mimic the function of a short segment of a gum plant lined slough channel in a mature tidal marsh. Now, to build these earthen islands, sediment is taken from a nearby excavation area. And the excavation area is basically a shallowly shaved down area to form sort of a low bench. And the excavation area should not be dug too deep. Otherwise, it'll have trouble revegetating, and there may be concern about the deeper material being excavated and oxidizing, which will actually create acid sulfate soils, which can create really harsh conditions for the refuge island to revegetate. Next slide, please. Design of our refuge islands has evolved over time based on our monitoring results. We initially began with a lower elevation for these islands and a narrower design, but we've gradually increased the elevations to now be about 1.7 feet above mean higher high water at design, so that they'll settle to be about 1.3 feet above mean higher high water after settlement. Mean higher high water is basically the average daily high tide. You can kind of think of it. We found that habitats have developed a little bit better on these taller islands. However, we want to be careful that we don't construct these islands so high that they'll actually convert marsh to upland. So we want to keep them being marsh habitat. The goal is to construct these islands so that the gum plant and other vegetation growing on top of them grows to approximately 1 to 2 feet above a king tide, which is approximated by the highest astronomical tide. We want to be able to provide refuge during those really extreme high tides. Next slide, please. After a site has been chosen, the next step is to establish an elevation control stake, which we set at mean higher high water. This allows the contractor to build the islands to target elevations compared to that mean higher high water. After we determine mean higher high water at each site, we'll install a PVC elevation control stake using a real-time kinematics GPS unit. Next slide. Then it's time to begin construction. A refuge island is typically hand-built by a crew of 5 to 8 people. And the first step is to set up marsh protection. Laying down plywood in their work areas and plastic visqueen in their laydown areas helps to disperse the force of the crew working in the area and minimize impacts to the surrounding marsh vegetation. Next slide, please. Next, the crew removes chunks of marsh sod from the footprint of the refuge island and the excavation area. The marsh sod contains the vegetation and the upper 4 inches of soil with a lot of in situ root fragments, and these chunks are then set aside until later. Next slide, please. Next comes the excavation and shaping of the islands. After the marsh sod has been removed, material from the excavation area is brought over to the refuge island to kind of begin building up and shaping that earthen mound. Temporary grade stakes are installed along the crest and the top of slope to demarcate the design grade compared to the elevation control stake to help guide the crew on how tall these islands should be built. Next slide, please. So after the island's been constructed and shaped and the elevations have been verified, then the crew replaces that set-aside marsh sod back on top of the refuge islands in the excavation area. and this helps to rapidly reestablish marsh vegetation in these areas, usually within one growing season we've seen from our monitoring. Next slide, please. Final step, to plant it up with nursery-grown plants. Usually between 60 to 70 gallon-sized containers of gum plants and 60 to 70 saltgrass plugs are planted on each island to help rapidly establish that target habitat that we're aiming for. Next slide, please. The result is a completed high tide refuge island. The total construction time is about 1 full day, and afterwards, these features become a permanent part of the landscape and are even visible in aerial imagery. You can see from the Google Earth snapshot taken there, you can see the little kidney bean pill-shaped features there. It's always kind of fun to scan through a marsh and see where you can find these features. Next slide, please. H.T. Harvey and Associates has been annually monitoring all of these islands for about a 5-year period, and the metrics we measure include refuge island height and excavation area depth as measured by a laser level compared to the elevation control stake, gum plant height and survival, total vegetation cover on the refuge islands and excavation areas, invasive vegetation cover, photo documentation, and more recently, height and cover of dense vegetation, metric developed by Point Blue. In this context, dense vegetation is defined as the height at which the numbers on a meter stick become illegible when held at arm's length. We added that dense vegetation metric to really acknowledge that vegetation besides gum plant can provide refugia for rail as long as it's dense enough to provide cover. Next slide, please. After 3 to 5 years, we'll also assess the functionality of the islands as high tide refugia. Minimum quality refugia provide the minimal level of cover needed to protect rails from predation during extreme high tides. These islands typically have gum plant or dense vegetation taller than 1 foot above the highest astronomical tide. High quality refugia provide the highest quality refugia for rails during extreme high tides, and these islands typically have gum plant or dense vegetation taller than 2 feet above highest astronomical tide. Next slide, please. So we've monitored the previously constructed 62 islands for 5 years and found that our islands settled between 0.4 and 0.7 feet over a 5-year period, which is about what we had expected based on our design elevations. The excavation area elevations had accreted sediment about 0.15 feet per year. And we found that on average, the gum plant height was nearly 2 feet above the mean higher high water level, and that the average height of dense vegetation was about 1 foot, and about 66% of the refuge island areas had dense vegetation taller than 1 foot, and about 29% of the refuge island areas had dense vegetation greater than 2 feet. And about half of the islands were providing high quality refugia, primarily driven by the taller islands that were constructed a little later on. Next slide, please. The most recent 20 islands that were constructed in 2020/2021, we've only got about 1 year of data on right now. However, generally, we've seen fairly similar settlement rates for the refuge islands and fairly similar accretion rates for the excavation areas. And in general, we've seen taller average gum plant heights, taller dense vegetation heights, and more cover of dense vegetation. And about 3/4 of these islands are providing high quality refugia. So very good results. Next slide, please. Here's just a couple examples of our photo documentation from a couple islands built at Dumbarton Marsh, constructed in 2021. And you can see that after just 2 years, the gum plant that was planted is quite tall now, and just as tall as our ecologist's hips there. And in year 3, we actually see pickleweed taking more of a prominent role on the islands. Next slide, please. Here's just a couple photos of an excavation area from Cooley Marsh, taken from pre-project conditions through construction and then through 5 years of monitoring. And you can see that just after 1 year in 2020 and 2021, that you basically don't see a difference from pre-project conditions. Next slide, please. And here's an example of a refuge island being constructed at Cooley Marsh, taken from pre-project all the way through 5 years of monitoring. And you can see that just after 1 year, it's actively revegetated very quickly and is looking great. Next slide, please. And so in conclusion, some of the lessons learned include that bigger footprint excavation areas allow for the ability to utilize shallower, more oxidized soils, preventing those acid sulfate soils from developing. We've seen that taller islands typically perform better. We've observed a lot of gum plant recruitment on our refuge islands, which has been really great to see. However, we've also seen that gum plant tends to struggle during drought conditions. However, we have seen that dead gum plant skeletons can provide sort of a structure for pickleweed to sort of arbor up through and grow tall and provide that refuge for rails. Next slide, please. And with that, we'll take any questions at the end of the next presentation. Next slide. And thank you, everyone.